So in this video, I will demonstrate how, after you are done with the model building process, how you can use explainX.ai to explain the model and find biases and then use that understanding to improve the model. So in terms of the use case, I will be using the data on Kaggle about housing values in suburb of Boston. And I have all of these variables, for example, crime, rate per town, proportion of non-retail business acres per town. I also have the amount of pollution in this area, when was the house built prior to 1940, and my forecasting variable over here is this MEDV, the median value of owner-occupied homes in $1,000. So my first step here is always to import the data, do some data cleaning and data pre-processing, and then build the model I have over here, XGBoost. And after I'm done with this model building process, this is one line by which you can just run explainX.ai. Just have to give the model name and your data to see this dashboard, which will explain the model. And so this shows that the LSTAT, RM, and CRIM are three most important variables, which will always change the prediction more if we change some values in these three variables. But this graph does not tell you that whether the LSTAT will increase the prediction or decrease the prediction. So to find that, we have this global feature impact graph, which shows that these are the three most important variables, and these three will on average increase the average prediction, which is 14.23. For example, this LSTAT will always increase the average prediction by 0.07, and whereas this RM will on average decrease the average prediction by 0.19, and similarly this age variable will on average decrease the prediction by 0.02. But this graph does not tell you that whether the age will always have the same impact on the prediction. Maybe like for different age values, the model will perform differently, and different age values will increase prediction and some will decrease prediction. And to find this pattern, I would have to go to the feature interaction graph, where you can choose the age variable and the impact of the age variable. And you can also choose a third variable. For example, in our case, let's choose the prediction value. And this graph shows that as you increase the value of age, the impact is becoming a bit positive. So the relation between the age and the impact is positive, means the houses which are older, right? If you increase the value of age, your prediction should always go up most of the times. But it's also possible that the model might behave differently for some subset of data. For example, if I have a variable gender in my data, I can also find out that how the model performs when the gender is only male, and how the model performs when the gender is female. And that comparison can help you find out whether the model is biased towards some gender or not. And similarly over here, I don't have a gender variable, but I have other variables here. For example, I can find out how the model performs when the level of pollution is more than 0.5. So my graphs will change automatically. And this graph shows that I don't have like so many data points when my age is less than 60, which means that it's really hard to trust the model when your age is less than 60 and your pollution value is more than 0.5. It's but we have like so many data points over here for the age more than 60, so you can trust the model in this scenario. And plus it shows that pattern is still positive even when the pollution value is more than 0.5. And sometimes the mod and to find out why the model is biased, it's highly possible that there are some extra data points for some values or some variable. For example, if you go into LSTAT, you can see that the data is evenly distributed and it's okay. But with text, you have some anomalies here. For example, it has a really high value and there is a gap between the distribution and these data points. So you have to check why you have these values in your data. Similarly, for example, if you go and see age value, uh, you can see that your data is skewed on the right, means you have more data points when your age is more than 80 or so, means the model will perform really good in this domain. But since you have less data points when the age is less than 27, the model will perform really bad in this scenario. Lastly, it's also possible to explain a single property. For example, why is the model giving 14 prediction given all of these variables? And to explain this, we have this local feature impact graph, which shows that the average prediction was 14.23, and this LSTAT variable, which has the value of 9.14, this LSTAT increased the prediction value by 1.77. And this NOx, which has the value 0.469, also increased the prediction, but by only 0.2, whereas this RM variable decreased the average prediction by 1.42, and the value of RM is 6.421. And it's also possible to explain these properties by using similar properties. For example, we have a module called prototypes, which finds similar profiles and try to explain the prediction for this property by using similar profiles, similar properties. And this shows that this property is 76% similar to this property on the top, which is why the value of the prediction is pretty close. Whereas this this property over here is only 19% similar, which is why the prediction value over here is 28.85, whereas what we have here is 14.9. So we have these similar profiles and local feature impact to explain each property or each data point. And if you want to find how the model performs on the entire data, you can just choose entire data over here. But we also have the option to find out how the model performs. For example, when your gender is male, gender is female, or when your age is more than 50 or the age is less than 60, right? It's all up to you. You can define any scenario you want, and you will have the explanation of how the model performed in that scenario. So this is what explainX will give you. And it's highly possible that you might find a pattern. For example, you might believe that this variable should always have a negative impact on the prediction, but the model is giving positive impact, means something is wrong with the model. So you can see if all of these are aligned with your own understanding. given that you are an expert in your domain. So if the model is aligned with your own understanding of how the world works, means the model is performing really good. It's able to capture all the patterns accurately, but you have now the option to see for yourself and decide. And then if you find some error, you can go back and change the data in and also your model, and then repeat the entire process until you are able to find the best model.